This video is going to cover Chapter 11, Section 6, and it's going to cover volume of prisms and cylinders. Whenever you find the volume of a prism or a cylinder, what we're going to be doing is we're going to be finding the area of the base, and we're going to multiply that by the height of either our prism or our cylinder. And we have three postulates here. The first one is volume of a cube postulate, and the volume of a cube is the cube of the length of its side. So you would take the side length and raise it to the third power. The second postulate is volume congruence postulate, and this states if two polyhedra are congruent, then they have the same volume. And the third postulate is volume addition postulate, and that is the volume of a solid is the sum of the volumes of all of its non-overlapping parts. So think of it as a complex figure, and you could divide the figure up into smaller figures that you would calculate the area, the volume for, and then add those volumes separately. So next is a theorem, and it's the volume of a prism. So just like I said in the introduction, the volume of a prism is capital B times H. Now, be very careful with this letter B, and notice it's a capital B or an uppercase B. And what that represents is the total area or the area of your base. So you're going to find the area of the base, and you're going to multiply it by the height of the prism. So notice in this figure, this is actually a rectangular prism. So what you would do is you would find the area of the rectangle and you would multiply it by the height. Now, you've probably seen this in middle school. In middle school, they probably taught you the formula as length times width times height. Because again, the length times width represents the area of the base, and then you're multiplying it by the height of the prism. If you learned a formula for area of a rectangle as base times height, and then you'd multiply it by the height of the prism. These two heights are going to be different. One will be the height of the rectangle base, and then this other height will be the height of the entire prism. So again, be careful. The formula for volume, this is a capital B, and it represents the area of the base. Don't confuse it with a lowercase b. Next, we're going to talk about a cylinder. So just like a prism, it's going to have a base, but this time our base shape will be a circle. So this example here is a right cylinder. And when you have a right cylinder, the segment that's going to join the centers of the circular bases is going to be your altitude, which is also known as the height. Remember, the height is always going to be represented as a perpendicular distance. So next, here is the official formula for volume of a cylinder. And again, notice it's got the capital B times H. This time though, the area of our base is a circle, and that formula is pi r squared. So again, the capital B represents the area of the base, and then I'm going to multiply it by the height of the cylinder. And again, our base shape, when it's a cylinder, it's a circle. So formula you can memorize is pi r squared times height. So let's go ahead and do some examples. So here is our first example. We have a cylinder, and I'm going to do this leaving it in terms of pi, and I'm also going to do the same problem, and I'm going to use 314 for pi. So in my figure here, the 5 is the radius, and the 7 is the height of the cylinder. So to find the area of the base, which is the capital B, the base shape is a circle, so pi r squared, and my radius is 5. So I'm going to square it, and I get 25 pi. It's an area, so it's centimeters squared. That would have been if I left my answer in terms of pi. Now let's do the same base area, but let's use 3.14 for pi. So here, 3.14 times 5 squared, 3.14 times 25, and I'm going to end up with 78.5 centimeters squared. For the volume, remember the formula is capital B times h, or pi r squared times the height. Well, I've already calculated the capital B, and it's 25 pi. And now I'll multiply that by 7. A lot of times whenever I'm multiplying something by 25, I think about quarters, because I can calculate quarters and figure out how much money it is pretty quickly. So 7 quarters is actually $1.75, so 175 pi centimeters cubed. The units on volume are always cubed. If I was using 314 for pi, I would take my 78.5, multiply that by the height, which is 7, and end up with 549.5 centimeters cubed. Next, we're going to apply the postulate, so the addition postulate there, and we're going to separate my figure into smaller shapes. So I'm going to go ahead and draw a dividing line here, and I'm going to find the the volume of this cube up top here. And notice it's 1 times 1 times 1, so this has 1 cubic unit, or 1 unit cubed. Now I'm going to do this larger rectangular prism down here, and I'm going to be multiplying the area of the base, which is 3 times 1, times how tall it is, which is 2. So 3 times 1 times 2 gives me 6 units cubed. Now if I want to find the total volume of this complex figure, I'm going to add my 1 unit plus my 6 units, and my final volume of this figure is 7 units cubed. I could also spell it out and say 7 cubic units. Either way. Next, it says to find the volume of a square prism that has a base edge length of 5 feet and a height of 12 feet. Now, a picture wasn't given, so I could go ahead and let's draw a picture. Let's see if we can draw one here. All right, well, that's a rough square prism, but it gives us a general idea. So we have 5 feet as the base length edge, and then the prism has a height of 12 feet. So again, remember the formula is capital B times H. The shape on my base is a square, so 5 times 5 times the height, which is 12. So 5 times 5 is 25 times 12, and my volume is 300 feet cubed. Next we need to draw a picture of a right cylinder. So let me draw my right cylinder here. and it told me it had a height of 18 inches. It wants me to find the radius. So if you recall, the formula for volume is pi r squared times height. Let me go ahead and replace what I know. I'm given that the volume was 684 pi. I do not know the radius, and I know my height is 18. So to solve here, I'm going to divide both sides by 18 pi. The pi's will cancel. 684 divided by 18 gives me 38. Radius squared. And then I'll square root both sides. And my radius is equal to the square root of 38. Now, if you weren't using a calculator, this is how we would leave it. If you were using a calculator, and if it said to round to the tenths place, then we would do the square root of 38. It'll give us 6.1644. So rounded to the tenths, 6.2 inches. Now this last example is actually an oblique prism. It sort of looks like it's slanted, but remember the height, or this altitude, is always going to be represented by right angle. It's always going to be a perpendicular distance. So this is the height, and then what we're going to do is calculate the area of the base. And notice my base area down here is actually a triangle. It's a right triangle. So what I'm going to do is, again, the volume is capital B times H. My B is 1/2 BH, or base times height divided by 2. So 9 times 5 divided by 2. And I get 45 over 2. So base area is 45 over 2 times the height, which is 8. I can go ahead and simplify diagonally here. So my final answer here for volume, 45 times 4, is 180 meters cubed. And that is it for volume of prisms and cylinders. So now you can go back and you can add these two formulas to your formula sheet. So when it comes time to take the test, you'll have your formula sheet all ready to go. So you're going to work on the homework. After you finish these notes, remember to complete them and submit them to the Canvas assignment, and then also complete the homework assignment. And I will see you at our next meeting.